IRC section R702.7 might look like legal gibberish, but it's actually straightforward once you understand the logic. So in this training, we're going to translate this code section into plain English so you'll know exactly when and where vapor retarders are required and when they're not. Here's the fundamental requirement. Vapor retarders go on the interior side of framed walls, but only in certain climate zones. The code divides the country of the United States into climate zones based on temperature patterns, and colder zones require vapor retarders while warmer zones don't. Why? Because vapor retarders control condensation problems, and condensation happens when warm, moist indoor air meets cold surfaces. No cold surfaces, no condensation problems, no vapor retarder needed. The IRC uses a simple climate-based approach. In climate zones 1, 2, and 3, that's the most southern United States along the Gulf of Mexico and lower Atlantic coast, no vapor retarder is required. The exterior weather-resistant barrier provides sufficient protection. But in climate zones 5, 6, 7, and 8, and Marine 4, the colder parts of the country, class 1 and 2, vapor retarders are required on the interior side of framed walls. These are areas where cold winter temperatures cause interior moisture to condense on exterior walls. Climate zone 4 gets special treatment. It's the transition between vapor retarders being required and not required, depending on specific wall assembly details. If your wall assembly meets certain performance criteria in the code table, R702.75, you can skip the vapor retarder even in zone 4. This reflects the reality that zone 4 climates don't always create severe condensation risks, especially with certain construction methods. And the code lists 5 important exceptions where vapor retarders aren't required, even in cold climates. First, basement walls. Below grade conditions are different. Second, below grade portions of any wall. That's the same logic. Third, construction where moisture won't damage materials like concrete blocks. Fourth, no vapor retarders needed in zones 1, 2, and 3 regardless. Fifth, zone 4 through 8, assemblies that meet specific performance requirements can skip vapor retarders. Those exceptions recognize that not every situation creates condensation risks, and the code explanation is simple. Water vapor moves from the warm side of an assembly to the cool side, and historically, codes required vapor retarders on the warm in winter side of walls. But research showed this isn't needed in warmer climates, where the temperature differences isn't severe enough to cause condensation problems. So the code focuses on preventing moisture accumulation that actually causes damage, not controlling every molecule of water vapor. The code also recognizes responsive vapor retarders, materials that are class 1 or 2 under normal conditions, but allow at least one perm when moisture levels are high. These smart materials provide condensation protection when needed, but allow drying when conditions change. This represents evolving building science that recognizes the need for both vapor control and drying potential. Here's an important point. Vapor retarders are just one part of wall moisture control. The code also requires water-resistant barriers behind exterior wall cladding with drainage systems. The vapor retarder handles interior moisture, while the weather-resistant barrier handles exterior moisture. Both systems work together for comprehensive moisture management, and the vapor retarders may also function as part of the air barrier system. For inspectors, this training provides clear guidance. Know your climate zone, understanding the basic requirements, and recognize the exceptions. And when you see vapor retarders where they're not required, it's usually fine. When they're missing where required, that's a potential code issue. Section R702.7 in the International Residential Code boils down to this. Cold climates need interior vapor retarders to prevent condensation. Warm climates don't. The the code provides specific climate boundaries and recognizes situations where exceptions make sense.